Okay, ladies and gentlemen, this material, again, college algebra, SALIC, this is going to be section 1.2 part 2. Now what these lesson plans are actually created from. There is a supplement that you'll find on Course Compass. So if you sign on to Course Compass, you'll see a button that says supplements, okay? I'd like you to print out the supplement that says supplement B1. This is basically used in conjunction with section 1.2. The department created this supplement, and there weren't enough problems in the book of this type, so that's why we're supplementing these type of problems. But the directions on supplement B1, and you'll see I've broken the problems into, parts so I can do my videos for you. The question on the supplement basically says this: state the domain using interval notation. So every function that's listed, you're asked to write the domain, and you're asked to write the answer using interval notation. Now on this supplement, we're not at all interested in the range, we're only interested in the domain, okay? The reason that I put problems 1, 2, and 3 together on one video, f of x equals 2x minus 3. 2x minus 3 is called a polynomial. And when you turn it into a function, this in turn is called a polynomial function. Likewise, x to the fourth plus 2 is called a polynomial. When you make it a function, i.e. g of x, it becomes a polynomial function. And h of x is also a polynomial function. Okay? So when you look at question 1, 2, and 3, they all fall in the same category. And actually, these are going to be the easiest problems to answer. When I'm asked for the domain of something, I want to know what I'm allowed to put in, what I'm allowed to put in for x. A very easy way to think about that is, what real number am I allowed to feed it? Okay, these are functions that are trying to eat. And a domain means what's on their diet. What type of food am I allowed to give them? Do they have any special diet? Or can I feed them any real number I want to? Well, this function takes 2 times whatever you're putting in and subtracts 3. What real number can you multiply by 2? Well, any real number, right? Any real number you think of on the real number line can be multiplied by 2. So the domain of this first function is any real number, which the way you'd say that is all reals. Let's look at function 2, which is also a polynomial function. What real number can you raise to the fourth power? Well, any real number can be raised to the fourth power. So the domain for question number 2 is also all real numbers. And I think you're kind of catching the drift here, that anytime you realize you have a polynomial function, okay, polynomial function is very clean. There's no radicals in it, there's no variables in a denominator, it's simply a polynomial. What real number can you raise to the third power? Any. What real number can you square? Any. What real number can I multiply by 5? Any. So, here's the deal that I want you to get in your brain. Anytime you realize that you have a polynomial function, all right, anytime you recognize that a function's a polynomial function, you can make this conclusion. The domain is going to be all real numbers. And we were asked to write our domain using interval notation. And of course, the way I would write all real numbers in interval notation is negative infinity, comma, positive infinity. And you need to make sure that these are parens, not brackets. And of course, the reason you're not using brackets is because you never reach infinity or negative infinity. These aren't even real numbers. These are just symbols saying the number line goes on to the right forever and to the left forever, and you're including the whole number line. So, in wrap up, anytime you have a polynomial function, the domain is always going to be all real numbers, and this is the way you write it.